Now, note that, look at my TU1. So those are the things which I have to find. Note that TU1, it is important to note that TU1 and TU2, these are in R3. They are in R3 because our transformation was taking elements from R2 to R3. So they are in R3, and the question provided me with the basis of R3. That basis for R3 was B prime. B prime having V1, V2, and V3. So if TU1 and TU2 are in R3, it means that they're in R3. Then it implies that. So this implies that TU1 and TU2 are linear. They are linear combinations. They are linear combinations of V1, V2, V3, like that. So they are in R3. Why am I saying that they are in R3? You see that they are made up of 3 coordinates. Look at TU1. It is 1, -2, -5. TU2 is 2, 1, -3, like that. So they are in form of R3. And I know what generates R3. R3 is generated by V1, as in the basis elements. Look at B prime. You have V1, it is made up of V1, V2, and V3. So if TU1 and TU2 are in R3, then they are linear combinations of vectors V1, V2, and V3. So therefore, what that means in particular is that this means that TU1 is equal to X V1 plus Y it means that we have alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3, and also TU2 is equal to alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3, like that. For some scalars, alpha 1, alpha 2, alpha 3. For some scalars, alpha 1, alpha 2, and alpha 3. So what is the key issue here? We find alpha 1, alpha 2, and alpha 2. We determine them. So now we substitute in those linear combinations. We are going to manipulate those linear combinations. Look at the first linear combination where I have TU1. So what is TU1? From my computation there up, TU1 is 1, -2, -5. equals alpha 1 times V1. What is V1? According to the question, V1 was given as 1, 0, -1 plus alpha 2. What is V2? V2 is 1, 2, 2 plus alpha 3. V3 is 0, 1, 2, like that. So I solve this for values of alpha 1 and alpha 2. This is a simultaneous equation. So I have to deal with this. Then I also deal with the other expression for TU2. That expression which you see on the... So this is what I am dealing with at first. The next, I'll do the same things for that one. The same things for that one. So what is the alpha 1? This is a simultaneous equation. Hope you agree with me that alpha 1 plus alpha 2 is a 1. That is the first equation. Then the second equation is 2 alpha 2 to alpha 2. Maybe I use row reduction. Okay, let me use row reduction.
Yes.
I have 1, 0, -1, 1, 2, 2, 0, 1, 2. Then this is equal to 1, -2, -5. Is equal to that. Yeah, so let me manipulate, because here I already have a 0. Here I already have a 0. Let me manipulate the first and the third. The first and the third. So that is R1 plus R3. So I'm going to maintain this. Then this is a 0, 2, 1, -2, like that. Then R1 plus R2, this is a 0. This is a 3. This is a 2. Then this is a -4, like that. That is R1 plus R3. Then I reduce this further. 1, 1, 0, 1, 0, 2, 1, -2. Then this is a 0. So what am I doing here? I am multiplying 3R2 minus 2R3 to get the last row. 3R2, 3 times R2 minus 2 times R3, this will be a 0. 3 times R2, that will be a 3 minus 2 times 2, this will be a -1. 3 times R2, -6, -60 plus 8, this will be a 2. That's what I'm getting. So meaning that negative alpha 3 is equal to 2. So over -1 over -1, implying that alpha 3 here is -2. Then also the second row, from the second row we have 2 alpha 2 plus alpha 3. 2 alpha 2 plus alpha 3 is equal to negative 2. So this is 2 alpha 2 minus 2 is equal to negative 2. So that implies that 2 alpha 2 is a 0 over 2 over 2. So that alpha 2 is also 0. Then first row, we have alpha 1 plus alpha 2 is equal to a 1. But alpha 2 is a 0. Therefore, alpha 1 is going to be a 1. So what does this mean? So for this setup, I have alpha 1, alpha 2, and alpha 3. For this first setup, this is equal to alpha 1 is a 1, alpha 2 is a 0, alpha 3 is negative 2. That. So I do the same thing for the other representation. Those alphas, they are the ones now that make up that block, which I was looking for. Maybe I write it here. So this means that TU1 B prime is 1, 0, negative 2. 1, 0, negative 2. Then I also solved the other linear combination, which I rubbed off. I emphasized it. So I'm going to just put that linear combination, which was having TU2. TU2 alpha 1 times V1, that linear combination. Now I repeat the same things for that linear combination still. I find alpha 1, alpha 2, the way it have been showing. So for that linear combination of TU2, I think it has been TU2 is equal to alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3. This implies that what is TU2? TU2, according to what I obtained earlier on, TU2 was 2, 1, negative 3. That was TU2. This is equal to alpha 1. What is V1? 1, 0, negative 1, plus alpha 2, 1, 2, 2, then plus alpha 3, V3, alpha 3, V3, 0, 1, 2, like that. So still I come up with a system and I apply row reduction. So what do I have? I have 1, 0, negative 1. Then 1, 2, 2, 0, 1, 2. This is equal to 2, 1, negative 3. Like that. Row reduce in the same way. We are not going to change much. So you see previously I used R1 plus R3. R1 plus R3. It is the same thing which I'm going to do here. This will be a 1, 1, 0. Equal to a 0. 0, no, equal to a 2. This is a 2. 2, 1, 1. Then if I add R1 plus R3, this will be a 0. This will be a 3. This will be a 2. and this will be -1, like that. I continue in the same way. How 3R2 minus 3R3. It will be a 1, 1, 0. One, 1, 0, 2. This is 3R2 minus 2. Minus 2, sorry. Minus 2. Then this is 0, 2, 1, 1. Then this is a 0. This is a 0. 3R2, 3 minus a 4. I think this is a -1. And 3R2, that is 3 plus 2, 5. So what do we have? -R3 is equal to a 5 over -1 over -1. So R3 is -5. Then also 2R2 plus R3 is equal to a 1. So 2 alpha 2 minus 5 is equal to a 1. So 2 alpha 2 is a 6 over 2 over 2. Alpha 2 my screen has frozen. It is failing to respond. My screen has frozen. Yeah, I think it has overworked. It's now not writing.
What was the last part? Hello.
A moment.
Hello.
Oh, this is not even.
Yes, sir.
Are you hearing me?
We are hearing you. We are.
I was saying that I'm saying that my screen has frozen.
And it is almost time to the next session, next lecture, online also.
Yeah, and I think I have exceeded by some 8 minutes. She had told me that I should stop at 10, if I recall very well.
Okay.
Yeah, so what is left here? You find alpha 2 and also alpha 1.
Alpha 2, I'm getting 3.
Alpha
Yes,
2 is
alpha.
-1.
1 is -1.
Yes.
Yeah, then you also form that column. So you'll be having a column made up of, you said
Alpha 1.
-1,
Mm.
-1, 3, -5.
5.
Mm.
Yes.
So the matrix, the required matrix is made up of those two columns. The first column which I first calculated, the first column which was having 1, 0, -2, that is the first column. Then the second column, will be having you've told me you've got what?
-1, 3,
Negative
-5.
1.
-1, 3, -5.
Yes.
Yeah, so that will be the required matrix. Yeah, that will be the required matrix. Allow me stop here. I'll pick up from there on next Saturday.
Thank you, sir.
Okay, have a blessed day.
Blessed day too, sir.